Taylor is a Lisp-like functional language, and from what I know, the first interpreted language by WebAssembly and the Ethereum Virtual Machine. Types and function definitions are stored in a smart contract which acts as an interpreter. The contract module receives the encoded Taylor source code and executes it, and we can see the result here. Now, Taylor has a multi-contract execution environment, which means that the blockchain is treated as an operating system, and we can establish cliques or groups of contracts that forward functionality in a transparent manner from one contract to another, and we can choose a contract to work on as the environment root, for example, contract 3 in our case. Now, contract 3 has 2 other contracts registered to it, so we can also use functions that live in these registered contracts. So in the first contract, we can define a function, quad, which just multiplies a number by 4. And we can save it on-chain and then use it. And we can see the result here. Okay, now if we go to the second registered contract from contract 3 and we try to run the same function, we get an undefined, because this second contract doesn't have the quad function defined, and it doesn't have any registered contracts that might have this function defined. But if we go to contract 3 itself, then we can use it. Now let's go to the second contract that we have registered and define another function, fib, which is the Fibonacci series. We store it on chain and then we can use it. And we have our result here. So going to contract 3 again, we can use both functions and it works. So what happens is contract 3 sees that it does not contain the needed function definitions, so it calls its registered contracts until it finds them. So Taylor smart contracts are upgradable, and they are just interpreters with some storage. But you can also give to a contract the entire source code of a function, and it will be executed. For example, this. Soon, Taylor will be on a testnet, available for developers to play with it.